Not on R, but specifically on the first quadratic.
This is exactly my question that I want to have from Ike. What about this? What is n?
Natural number.
Is natural number. First of all, can we define this? Can we write something like this and say that is these sets of vector space? So to the people who may watch this video, we know that this is wrong because the definition was that we define sets of vector over a field. So n is not a field. So this is this. But imagine we came up with such a set which guarantees everything, that we don't have the negative. Still, can we have this vectors to be a vector space?
Yes. Because the constant will.
Yeah. Can you check property number 6? Yeah. So definitely we have lots of properties which fail, even though if we could take care of this, which we can't because this must be a field by its own. Actually, so this one actually fails simply because property number 6 fails. Property number 6 fails. Now, Hassan, I ask you one question. Okay. I mean, you ask lots of questions from me. Now it's my turn. And the question is this. But this is an open question to everybody. Is it or not? And if not, tell me why not. But if it is, you don't need to prove it, then we can easily go over all the conditions and check them. Talk with your feelings, you know. You should have a feeling that if it can be or it cannot be. I mean, because if your feeling says it can be, then you can start to prove it. If the feeling says it cannot be, then you start to look for counterexample.
What if you have two of these vectors and you add them together? You end up in the form.
So basically, you want to say no.
No.
Okay. That's true. It is not. And simply, we can do this. Look at the condition number 1, addition. Addition of the two vectors should be inside the field, right? Inside the vector space. But we know that if we were adding these two, I don't know, I'm very bad in drawing, this will be the result of the addition, which basically fails. Right? What if we have this? Sets of vectors in 2D Cartesian coordinates. Is it a vector space?
Yes.
Yes, this is actually R2 and R, which already know R and R is a vector space. Right? So it's like all the Cartesians. Now, what we tried to do in the previous examples, which we said that they are not vector space, we tried to take some bunch of vectors from the bigger society of those vectors to check if something is happening. For instance, we know that R2R is a vector space In previous example, we tried to get some bunch of those vectors in R2 and try to see if they are vector space. Now, if we pick up some bunch of vectors from the vector space and they are forming a vector space, we call this bunch a subset of the actual vector space. So subset means, by its own it's a vector space, but it is under a very bigger society. It's under a very bigger society, right? So let's talk about subspace.
So in this case, the first quarter would not be a subspace because
No,
it's part.
first, it's not a vector space at all. So I mean, it's just if and so can you read this for me? Can you read this? We can write it in this form. If V is a vector space on field F. So instead of writing all this, I just put this notation. Okay? And S is a subset of V, and S is not empty, then S is a subspace if only we have two conditions to satisfy. For any S and T belonging to S, then S plus T also belongs to S. And for any S belonging to S and A belonging to F, then AS belongs to S. So I mean, in the book we have them with the capital letter. Again, for me, my capitals and lowercase are very similar to each other, so I put it in this fancy format. So let's look at some examples. So here we have only two conditions to check. We don't need to check for anything else, like for the vector space, because already we say that S is a subset of a bigger vector space. So it means it has, if it is a subspace, it might inherit some of those properties. Now, example is this. In the vector space of R2R, any line that passes through the origin is a subspace of R2 and R. So because what is R2? What is R2? R2 means that any point in the Cartesian. So when we say when we say that lines passing through the origin, means those points that we are connecting them to the origin. So it means a specific line, because in R2 basically we can have infinity many lines which pass from the point 1 and 1 and 1 and 2, right? Or 1 and, I don't know, 3 and 2, not necessarily going through the origin. Now the question is that from all these infinity many lines, those infinity many lines which pass through the origin is a subspace of our vector space. And of course, not because I say, you have to prove it, right? We have to prove that it is true. Let's see how we are proving it. Do you have any idea how to prove it? Let's say S and T belongs to S. Also, X and Y belongs to S. If we say that S and T belongs to S, what does it mean? It means it forms a line which passed through the origin. Do you know what is the equation of a line which passed through the origin? It's AX plus BY is equal to Z. Lines, any line which passed through the origin means AX plus BY is equal to 0. This is the general equation. So it means that AS plus BT is equal to 0, which means that AX plus BY, let me not use the X and Y, so you will not confuse it by this general form. Let's say U and V. Then we have AU plus BV is equal to 0. So, look, we are going to do set 1. We want to do, sorry, the condition 1. Condition 1 says that, condition 1 says that if this belongs to S, if this is already true, and if this is already true, their addition must be also in S. The addition must be also in S. In other words, what we have to add these two, which will be AS plus BT plus AU plus BV. The question is that, is this one 0? If it is, we have to prove it, and it has to be in the form of AX plus BY. So I put the A terms together plus the B terms together. So it is in the form of AX plus BY equal to 0, which means that thus S and T plus U and V belongs to S. Right? Now, S and T belongs to S. S and T belongs to S. And let's say for C belonging to R, then we have A CS plus B CT is equal to CAS plus CBT, which is equal to C multiplied by AS plus BT, which we already know that AS plus BT is 0, which is equal to 0. So this belongs to S. So it means that C multiplied by any elements of this one also belongs to S. Right? What we are doing is this. We have to check these two conditions, right? We have to check these two conditions. Condition number 1 says that pick up any two elements from S and see if their addition is still in the S. So I pick up two elements in S. Remember, now because we are talking about R2, we are not talking about one single element. It means it's a vector. It's a vector. It has two elements inside this vector. So I have this pair, this couple in S. I have this couple in S. But being in S has a special meaning. It means it has to satisfy a condition, like it was a non-singular matrix before, which means that the determinant was not 0. So here it says that being in S means you are in the form of ax plus by is equal to 0, because you are passing through the origin, which means you are passing through the origin. So it means that if st belongs to S, so as plus bt is equal to 0. So this is still assumption. uv belongs to S means that au plus bv is equal to 0. This is also assumption. The question is that what will happen if I add these two? Do I get to the form of ax plus by equal to 0? So what I do is I multiply, I add them. I add this plus this, which means I add this term plus this term. So I am putting the a parts together and I'm factorizing a out. I am putting these two parts, b parts together, I factorize in b part. So I can see that this is in the form of ax plus by equal to 0. So it is satisfying the condition of being passing through the line, a line passing through the origin. So the addition of the two is also in S. Condition number 2 was saying that, okay, take an element of S, any element of S. So I am picking up any element of S. And the conditions here, what does it mean? S and T is if belonging to S means that AS plus BT is equal to 0. And it says that multiply it with any constant, which is in our field, which is, our field is defined to be R. So I'm picking up any real number, I multiply by our vector, and I have to see that this is valid. In other words, if I am multiplying this by A, I have to come with a constant C, I have to come with this. CAX plus CBY is equal to 0. So I am coming and I am multiplying my elements, this one with C, which means that it is CS and CT. So my pair is CS and CT. So I'm replacing them into the equation. So it's ACS plus BCT. I'm factorizing C out, and I come to the CAX plus CBY equal to 0. Which the condition is satisfied. If one of these two conditions fails, either with a counterexample or with a proof, it fails, then we say that it is not a subspace. Because then this set is not a subset of the bigger set that we have. Donna, is it clear?
Yes.
You sure?
Yeah.
So you are ready for my question?
I'll try.
Sorry.
Yes.
You use ST there and you use ST as elements in that set, so yeah.
Alpha, beta, and alpha and beta. They are dummy variables. What I try to say that this element should satisfy my condition. If it was R5, then I will have like S1, S2, S3, S4, S5 because they have to form this 5 input. Now, Donna is ready for my question, and it will go like this. If Donna fails, I fails, Hassan fails, Prit fails, Shah. Okay. Can I erase this part because I want to use the same question? in the vector space, in the vector space of R2 and R, any line that does not pass through the origin is a subspace. True or false? So we saw that if it passed through the origin, right, it was a subspace without any problem. Now we want to see that what about those lines which they do not pass through the origin? What does it mean a line does not pass through the origin? I mean passing through origin mean this: ax plus by is equal to 0. Not passing through origin means ax plus by is equal to k, where it is not 0. Right? This is the general equation of a line. This is the equation of a line. So the question is that, show that whether this is subspace or not. And Donna will tell us if, in her opinion, this is a subspace. If it is a subspace, we have to do the same 2 steps. If it is not a subspace, either you have to do the 2 steps and show that it is not, or you have to come with a counterexample.
Well, I think it is a subspace.
It is subspace. Very good.
Because if we replace during the same way, we will show that they belong to S and T.
I don't know, I'm asking you a question. Okay, Donna, you come to the board.
Okay.
Pick up one color that you like and prove or disprove. I mean, write down what you try to say.
Well, we should replace in the same way we replaced before, right?
Yep, exactly. I mean, the strategy is the same.
Well, we said that S and T
Belongs to,
S.
it's not a euro, it just belongs to, it's one line.
Yeah, I know. Okay.
So what does it mean?
It means that we should put in this equation the same thing.
Put it, let me see.
A S
Yes.
plus B T should be equal to K.
Okay, very good.
Then U V
Very good.
belongs to S. Then we have US plus VS equals to K. And we should
US, BS,
oops.
oops,
T.
UT,
Yeah. VT. Actually.
why V?
Because I wrote U and V.
Why did you write S? What is constant and what is a variable? In the AS plus BT, what are constants?
S and T.
No, they are changing. They are S and T are belonging to S. They are,
Yeah.
so A and
A
B.
and B.
So why the A and B have been missed in the second one? Look, equation of the line says that constant AX, constant BY.
Yes.
So this A is here, this B is here. So why they are not here?
Because I'm using.
No, then it should be AU plus B.
Yes.
AU plus
B.
Your P is nice. It's like the Donald Trump's hair. Okay, add them, add them. Is equal to? 2k. Okay, stop here. Turn to the Hassan and ask Hassan if this vector belongs to S. Ask him.
Doesn't belong.
Preet. Does it belong to S?
No.
No. Because belonging to S means A x, give me this, A x plus B y should be
Okay.
K. Oh, it happens that 2k is definitely is not equal to k, so it's not a vector. Thank you very much. It's not subspace. So this is like mathematically proving it. But if you are a man who loves counterexample, you can prove it with a counterexample. This is 0, 1. This is minus 1 and 0. This is 0 and minus 1. This is 1 and 0. My bad line. Add these two, what do we get? L1, this is L2, and this is L1 plus L2. So this is a very, very obvious. Or maybe you don't know this geometric and you cannot draw it. Even we have a much simpler example. This is y is equal to 1, this is y is equal to minus 1. Add them, you will get the x-axis which pass through the origin. So, simple counterexample. But this is a very solid proof to say that this is not. You see, actually these include much more, in general, much more of those vectors. But this is not a subset. Not subspace. You wanted to ask something and I was interrupting.
No, I was just thinking about trying to prove it geometrically, so we just plot it.
Yeah, okay. But remember, counterexample is one way, or you can just simply write it down. So you wrote it down correctly, but your statement was wrong, that this is a subspace. It is not a subspace. So, a question to Hassan, right? Remember, answering correct or wrong is not like any bonus or any negative point. It's just like we try to keep the things very interactive. So the example, the question is this. Are all matrices of form 2, A12, 0, A22, a subset of R2R. We know that R2R is vector space. Now the question is, we have defined this set, this subset out of this bigger set, which are matrices which are forming in this shape. 2, 0, A12, or A22. The question is that, is this subset is a subspace of, I mean, definitely it's a subset, but the question is it a subspace of R2 and R?
We got no restrictions over A11 and A22.
Sorry?
We got no restrictions over A12.
No. There are. I mean, any real number.
No, it can't be a subspace.
It cannot.
Yeah.
Maybe you come here and you prove or do either with counterexample or as please as Dana did mathematical proof on disproof. Except blue, pick up another color and yeah.
So if we try to prove it like adding two elements like so
I can understand. You know it very correctly. Just write it down.
okay, so maybe it's 2, 0, and this could be any numbers. So if
So do it symbolically.
A1 and A2,
This belongs to S.
Yeah.
Right, belongs to S. So write another element in the S.
So maybe it's it has to be 2 and 0.
Yeah, and again, parametric form. But don't use A, come on, you use A. Another element, like B1.
Yeah.
This also belongs to S.
The question of adding.
Yeah, and you want to add them.
Yeah. So it's going to be 4, 0, A11 plus B11 and A22 plus B22.
Which,
So, does not belong to
so
us.
right, does not belong to S. Excellent. So, one example, one counterexample. First element, this element belongs, thank you very much, Hassan. This element belongs to S, and this element also belongs to S, and their addition is not in S. Why? Because being in S means that this should be 2, 0, whereas this is 4, 0, so it is dismissed. Second, you could have a counterexample from the second one. You could multiply it with any number. Look, C belongs to R minus 1. If you have this condition, then we know that C multiplied by 2, 0, A12, A22 is 2C, 0, A12, CA12, CA22, which does not belong to S also. Because only for 1, if C is 1, we will get the same thing. Otherwise, we don't get the same thing. So you can have infinitely many counterexamples in here, as we had infinitely many counterexamples in here. So, we know what is a vector space, we know what is a subspace, and now we want to introduce another type of a space which is called a column space. C in parentheses A is column space of matrix A, which includes all the linear combination of columns of A. Which means this. The CA in a subspace is a subspace in R3 if A is 1, 2, 3, 1, 2, 4, 3, 3, 1, and basically CA is this, is the sets of alpha 1, 2, 4, so CA is vectors which is formed in this form. Now prove that it is a subspace of R3. So we have to prove it's a subspace of R3. So in order to prove it, we do this. We say alpha 1, 2, 4 plus beta 3, 3, 1. This belongs to CA.